So welcome to the next recording, and in this video I'm going to show you how you can improve your quality of data and how you can make your confirmatory analysis a bit better. So what we have here, we have some issues with the average variance extracted. Actually it is not an issue, it's very close to 0.5, and I think you can always argue that it is almost 0.5, or you can say that you use the less conservative cutoff value of 0.4 by CQI and Diamantopoulos. But we can also do something. First, if I click now to make it new, it will not work. We just do the following: we just copy this table just so we know what we had. We create a new file and paste it here just so we know. I'm not going to click on renew because it will anyway have a mistake. And we are going to start the tool again. We now go to our model, and we can do the following things. First, we go to the results and we go to modification indices. Modification indices will show what are the correlation between the error terms of your items, and you see we have some error terms that are correlated. And we have like two approaches. The first one is less conservative and one is the more conservative approach. The more conservative approach says that you are not allowed to correlate error terms if the items are not related to each other directly. For instance, if the one item is how frequently you use technology A on Monday and the second item is how frequently you use the technology on Tuesday, then of course they are related, they are very similar, and the error terms will also be very similar, so they will be correlated, and you can draw a covariance or correlation here. The less conservative approach says as long as the items are within one construct, the error terms can correlate, just because the items are actually measuring the same, just from different points of view. We are going to pursue this less conservative approach, and we can just see what were the items correlated. As long as they're within one factor, we can correlate them and it will improve the model because we kind of will control for the effects. Let's see. E14, E16, they are 14, 16 within one construct, so we can draw a correlation here. Then we have E5, E16, they are within different constructs, so we cannot do it, even less conservative manner. 5, 15 different, 3 and 4, and they can be also correlated. If we run the model will become a bit better, but before we do it, I show you what else we can do in this model. We have to run the model because now after we made some changes, the results disappeared. So what we do, we save the model as, and we save it as 002, and we make modification indices, just that we know that in this model we included modification indices. So now we run the model again, and here is the model fit. And model fit, as you can see, became a bit better, or remained the same, so at least it became a bit better here, it was just perfect here, which is impossible. It means there is a mistake, but again, the most likely mistake is that these are the generated data, where CFI index is looking at the model and thinks it is perfect. In real life, you usually will have much lower number, and you will have to think about how to improve it. So, degrees of freedom, significance improved, became less significant, which is good in this event, so actually the model became a bit better. But if we again run the discriminant and convergent validity analysis, we'll have the same issue because we didn't change anything. But we can change something. We go to our results, we go to estimates, and we look at the loadings. You find them under scalars and standardized regression weights. These are the weights. You see by BIS scale, they're all very good, all above 0.7. By BAS, actually, these two can be deleted. Let's take the moderate conservative approach. We take the items that are higher than 0.65. The rule of thumb says that you should have at least 3 items for each construct. I have seen models with 2 items, and even established models like technology acceptance models sometimes use only 2 items to measure a latent construct. But the rule of thumb is 3 or more items. The more items, the better, because it's the latent construct. The more questions you ask about it, the better you approximate this latent invisible construct like happiness. You can ask many questions about happiness, and then you can understand whether the person is happy or not happy. And we're going to delete the items 3 and 4 from bus RR, and let's see, actually this one is okay, over 6.5, over 6.5, or 0.65, 0.65, so we need to delete the 2 items, RR3, RR4. We go to the main model, deletion, and this is the 3 and 4. I think it was 3 and 4 that we need to delete, or 4 and 5. I forgot, but we'll find it out in a second. Then we have to run the model again. And let's go to the results. And we go to the model fit. And it became a bit worse here, but actually became finally a bit better here. Less ideal here, much better here, better here. REMC became a kind of bit worse, but still almost perfect, because everything which is lower than 0.04 is good, and we are much lower, so actually very, very good. Let's go to estimates, and we go to our standardized regression weights, and you see now almost all loadings are higher than 0.7, a part of these two, but we just keep them here, it's not so bad. When you delete items, think of the following, that you need to have these constraints on one of the arrows going from the latent construct to the item. If you had deleted this item, this one would disappear, then you have to manually introduce it here, let's say a regression weight, and you have to restrict it to 1. We don't need to do it because we deleted item 3 and 4. And now we do the same as we did before. We take our results, which are somewhere here. We take the correlations table and paste them to Excel. Validity must correlations here. We take the standardized regression weights, we paste them here, and now we run the model. And you see it became almost perfect. We didn't change the bus FF, the one that we changed was bus RR, and look, it became much better. We can improve it even further if we delete one of the items from the bus RFF scale, and it will immediately improve the model. I'm going to show it to you, and then we're going to work with that model. So I don't want to save anything. I hope I didn't save it, but we'll find it out in a second. We go to this item, to our results. Let's see which item has to be deleted. We'll delete, how many can we delete? We have 4 items, so we can delete only 1, because otherwise we'll break this rule about that should be at least 3 items. We'll delete this one, FF3. And let's go to the model. We delete item FF. I think this is 1, 2, and 3. This item can be deleted. We run the model. We go to our model fit, will be even better. We go to estimates, scalars, we take correlations, copy table. Now we need to start again our stats tools. I hope I haven't saved it, because otherwise we will have a problem. No, I haven't. Correlations, paste them here. We go to now standardized regression weights and paste them here. Run the model, and most likely it will be almost perfect. And it is perfect. So now we have the confirmatory factor analysis where we confirm how the items can be used, and we can use them in our structure equation model. Remember, in the exploratory factor analysis we retained all items, and in the confirmatory we had to delete some of the items. So it means that in the final calculations, when you're going to make aggregations, make your items, you will need to delete the items that we also deleted in the confirmatory factor analysis. If you stay in AMOS, you don't have to do anything, they are already deleted. If you want to go back to SPSS and create new factors, you will have to delete the items bus FF 3 and 4 and bus R, I think 3, and then the model will become even better. your calculations list will be correct. And you have all the values that you need here. You will need to calculate new Chromebox alpha. They will be very close to composite reliability, CR score, and actually we're good to go. So let's go to our model. What we do now, we're going to save this model. We call, yeah, did it work? Save as. We call it 003, deleted items, or you can call the clean model, whatever. So in the next video, I'm going to show you how you make the calculations similar to what we did with regression analysis, and then we're going to build a model which will be a kind of a fake model, because of course these items, they're from different scale, but we'll assume that they are related in a certain way. See you in the next video.